You can use search algorithms to check for a target element in an array and retrieve the element's position in the array. Linear or sequential search algorithms examine each element in the array in sequence, working from the beginning of the array to the end in a linear fashion. The best case performance of a linear search is O1. The average and worst case performance of a linear search is ON. Linear search checks each element of the list in sequence until a match is found or the whole list has been searched. When a match is found, the algorithm reports the position of the target element. If the end of the array is reached and no match is found, the algorithm reports that the target has not been found. Interval search algorithms break the array into smaller parts to be searched. Interval algorithms are more efficient than sequential search algorithms, but they need data to be sorted before searching. Taking binary search as an example of an interval search, we can look at performance. The best case performance of an interval search is O1. The average and worst case performance of an interval search is O log n. Binary search is faster than linear search except for small arrays. Let's look how binary search works. Remember that like all interval searches, binary search requires sorted data. It compares the target value to the value of the item at the midpoint of the array, determines if the target value is greater than or less than the midpoint, disregards the half that cannot contain the target value, and then repeats the process with the other half of the array. In this example, we'll use a target value of 27. The midpoint of the array is 19 at position 7. First, the algorithm checks to see if the midpoint is actually the target. 19 does not equal 27. The algorithm then checks to see if the target is greater or less than the midpoint. 27 is greater than 19, so the left half of the array containing integers less than 19 is discarded and the process repeated. In the next iteration, a new midpoint of 38 is determined and compared to the target. 27 does not equal 38. The algorithm then checks to see if the target is greater or less than the midpoint. 27 is less than 38, so the right half of the array containing integers more than 38 is discarded and the process repeated. In the next iteration, the new midpoint is determined to be 27 and compared to the target. 27 is our target value, so the algorithm reports the element found. Binary search took 3 iterations to find the target. A simple linear search would have taken 10.